Good morning. Today we're going to talk about GCF, which is the greatest common factor, and factoring. We're going to have problems like that are binomials and trinomials and all different kinds of polynomials. And I wanted to show you how to factor each and every one, which I want to remind you is basically like the opposite of distributive property. So distributive property is your nice check. So say you have a problem like this, it's 14x cubed minus 16y. You're looking about what is in common between 14 and 16, and you want to pull out the greatest common factor. So what multiplies into those numbers? So for example, 14, obviously 2, 7, 14, all multiply into 14, right? They're factors of it, and 1, but 1 doesn't matter. It doesn't make the problem any simpler. And then 16, same thing. It's 2, 4, 8, 16. So which one is in common between those, and what's the greatest? The greatest number that I can factor out is a 2. And what that basically means is I'm going to divide both 14 and 16 by 2 because the opposite is distributive property, and that's multiplication. And then looking at my variables, I'm not done yet before I start doing that division. I gotta look, is there anything in common in those variables? I have an x cubed, I have a y. No, they're two different variables, so there's nothing in common. Say I change this y to an x, there would be something in common, and I'll show you that over down here in number 3. Okay, so my greatest common factor is a 2. I'm gonna leave some room because what I'm doing here is I'm dividing each of those terms by 2. 14x cubed divided by 2 is 7x cubed. And then negative 16y divided by 2, that's negative 8y. And then if there's more to factor out, I would see that I could divide by more, but 7 and 8, there's nothing in common. X cubed and y, nothing in common. So my answer is that right there. All right, number 2. If you look over here with me, I have x cubed plus 5x squared plus 7x. I'm looking at 3 terms now, but it's the same idea. My coefficient here is 1. So there's going to be nothing I can divide all 3 by, numbers-wise. And then I look, x cubed, x squared, x. Is there something in common? Yeah, and I want the most, the greatest amount I can pull out of all 3. Well, I have 3 x's here, I have 2 x's here, and I have 1 here. So the most I can pull from all 3 is the smallest variable, right? The smallest amount. The smallest amount is an x. So I'm going to take out an x, and that's the most I can do because there's no numbers and no other variables. And then what I'm doing is dividing each piece by x. So then x cubed divided by x, those exponent rules are coming back. What am I doing? Oh, I'm subtracting, and I got to remember that an exponent, if there's nothing there, it's like a little 1. You need to see that a little better. Okay, so there's nothing there, then it's like a 1. So 3 minus 1, that's x squared, right? When I'm dividing, I'm taking 1x away from 3 of them. Plus 5 divided by 1 is plus 5. X squared divided by x is x. Plus 7 divided by 1 is 7. X divided by x is 1. 7 times 1 is that 7. Now, here's the trinomial, and if you remember, like, we factored trinomials. What multiplies, we have to remember X games, right? We have to find what multiplies to C, the third term, and what adds to B. So if I could go further, I would, and I'm looking at this, what multiplies to 7? What multiplies to 7 is 1 and 7. If I add those up, do I get 5? Not possible. So I'm done in this problem. Could I have gone further? Sure. All right, the next one, 4x cubed plus minus 10x. Now this is a case where I got to look at both numbers and the variables because I have both in common. I have 4 and a 10. What's the most I can factor out of a 4 and a 10? A 2. I didn't sneeze. All right, so I'm factoring out a 2. That's definitely one of them. But that's not all. So I don't want to write my parenthesis just yet like that, right? You want to make sure that you look at both things, right? Both parts of it, of the term. So I have a 2 for the number, but my variable, what's the most amount of variables I can pull out? Remember, it's the smallest one, so it's 2x, and then what's left goes in between. A lot of people forget to divide both pieces, so be careful with that. So then we're dividing by 2x, we're dividing by 2x. 4 divided by 2 is 2. X cubed divided by x is x squared. Negative 10 divided by 2 is negative 5. X divided by x is that 1, so there's nothing left. All right, so then I'm reminding you about x games. I kind of already did that. When you have a trinomial and it's a quadratic, there's a square there. You have to find what multiplies to that last term and adds to the middle term, and then we're going to turn it into a pair of binomial factors. And here's why. Remember multiplying, right? How do I get this first term? I get it by multiplying the first by the first. So x times x is x squared. How do I get this last term? Well, it's got to be these two numbers. So let's say 2 times 2. And it's positive and that's positive, so let's say it's all positive. Well, when I go to check this, I know my first is right. X times x, that's x squared. I know my last is right. 2 times 2, that's 4. But the middle part, that's the funny bunny part, right? When you multiply, when you do FOIL or your box method and you multiply all 4, you get x squared plus 2x plus another 2x plus 4. So my start and my finish, notice how they're good. I don't really even have to check those. Only thing I have to check are my inner and outer, right? The 2x, because I know my first and my last. And my inner and my outer, when I add those, 2x and 2x, I get 4x, not 5x. So I know this doesn't work, which is why we like to think about our factors before we actually do that, right? So we think, what multiplies to 4 and adds to 5? Well, it's either 2 and 2 or 1 and 4. Do either of those add to 5? Oh yeah, 1 and 4. So this is going to be x plus 1 times x plus 4. Now remember that if you wrote that the other way, that's fine, right? 4 times 1 is 1 times 4. So it's totally fine. And then you're welcome to check this, right? Check your inner. 1 times x is 1x. Check your outer. 4 times x is 4x. Add them up, and you get 5x. So you know this is right? I'm cool with you showing me that you did that, but just make sure that you circle the right answer. That's not your answer. This is your answer. You factored it. All right, guys, so all we have left is our last problem. So here I'm looking at a trinomial. Again, it's x squared, so I know it's got to be x times x. So I'm thinking, okay, how can I get that? Well, I need to see what multiplies to negative 10, right? This value, and it's a negative this time. And what adds to negative 3, this value here. So because it's a negative, right, I have to remember how I multiply to get a negative. 1 has to be positive, 1 has to be negative. And then my factors of 10 are 1 and 10 and 2 and 5. So which set of these, if one's going to be positive and one's going to be negative, that's really subtraction. So which set of these subtracts to 3? Oh, okay, 2 and 5. But then you have to think, well, I need more negatives, so which one has to be negative? The one that's more, right? So that 5 will be negative. So I have x plus 2 times x minus 5. If you want to test it, right? X times x, that's x squared. Yay. 2 times negative 5, that's negative 10. Yay. So all we got to look for is the middle. In the middle, we look for by doing the middle two numbers. 2 times x is 2x. And we add the outer two numbers, which is negative 5 times x, which is negative 5x, and you add them and you get negative 3x. All right, so that's factoring.